Hi, everybody, and welcome back. So, currently, we are moving on through our PowerPoint. And with this video, we are going to start with waves and tides. Waves and tides. So, there's our heading, waves and tides. So, what exactly is a wave? Well, waves are when water molecules bunch up and all move in one consistent direction. In fact, it is this circular motion that drives a wave. And you start to get these breakers right here when the bottom of the wave starts to hit the shore and it disrupts it and it starts to fall over itself. You'll see a diagram a little bit later. But exactly what is a wave? It's a transmission of energy through matter. And the matter in this case are the molecules of water. So if you were to actually look at a wave, the water molecule stays stationary and it just oscillates up and down, just moves up and down. But as it moves up and down, it's transferred. The energy is traveling from one molecule to the next. Okay, and you'll see a nice simulation of this a little bit later when I ask you to go on to a website to view the simulation. And I will tell you what that website is. So waves are caused by disturbing forces. Wind can cause waves. Seismic activity, earthquakes underwater can cause waves. Volcanic eruption can cause waves. These cause tsunamis. And you know that when you have this fracturing of plates, those two tectonic plates that move or slide past one another, or come towards or move apart, there's some crack, there's some friction that lets go. And when they do, they send a seismic pulse up that's felt by the wave, the water molecules, and that needs to now distribute that energy in the form of a wave. As the wave moves, it starts to pick up certain characteristics. And these characteristics, I don't care if you study physics, if you study oceanography, if you study chemistry, any type of science has these same characteristics. They are wavelength, measured from the peak of one wave to the peak of the adjacent wave, the wave height or the amplitude. This is known as the peak or the crest. This is known as the trough. Okay, so those are the four major parts of a wave. Now, the question becomes, do marine organisms, since we are talking about oceanography, do marine organisms feel the effects of waves? And the answer is, it's all about perspective. So, water deeper than half of a wavelength is not impacted by waves, which means, if we're looking at this example right here, from the peak or the crest of this wave to the peak or crest of the next wave, that is considered one wavelength. So if you take this distance and cut it in half and then swing it down, anything that's deeper than this does not feel the waves. So if the marine organisms, the fish, if they are underneath this area, they don't know what's going on up there. Okay? They do not feel those waves. But if they're above, they feel that circular motion. They feel that oscillation that's moving them. But if they're below, they don't feel a thing. So fish usually do not feel those storms that are going up above if they are below half of the wavelength. All right? With this slide, this just looks at, can wind speed drive waves, surface currents? And yes, it can. When we have a wind speed of 20 kilometers per hour, that will equate a wave height to roughly a third of a meter, or 1 foot. Remember, a meter usually is roughly 3 feet. Ramping up, if you have 50 kilometers per hour, you're looking at 3.2 meters, or about 9 to 10 feet of a wave. Then if you go all the way to a 90 kilometer per hour wind, that will create almost a 14-meter wave. Okay, which is quite large. And moving on, our last slide for the day looks at, can waves affect one another? And yes, they can. It depends on if they're in phase or out of phase. This is an in-phase wave, and we notice that when the two waves are on top of each other, the purple and the yellow, they actually build. However, when the waves are out of phase or opposite one another, they will cancel out, and you'll actually get no wave. Okay, that red line is the addition of the two waves. Here, there's no wave. Here, it is built. So hopefully this helps you a little bit with waves. I'm going to put another video on here explaining your assignment, so please view that one. Otherwise, I will see you guys in the next video.